All right, today we'll be looking at a very important topic in mathematics, and that is probability. And now, to move straight to this video, we'll be doing more of explanation. We need to have a solid foundation on this topic so that we can be able to tackle any example whatsoever. So, the definition goes this way. Probability is a branch of mathematical statistics basically concerned with drawing conclusions or inferences from occurrences or experiments involving uncertainties. As the name implies, probability. You are not sure. It's just like a guesswork. So uncertainties. So it is just drawing conclusions from these experiments that involves what? Uncertainties. Now we said, what does statements such as, so we're trying to get some statements under this probability so that we can be more clear, can understand it better in mathematical expressions. So what does statements such as Nigeria will probably win the football match against Norway. So will probably, we need to get to the end of that match to be able to tell if Nigeria will win or not. We can't tell. We can't give a conclusion. We must draw the conclusion from what? Uncertainties. We do not know who will win until that person wins. So another example is you will probably pass SSCE until the exam is conducted and until the result is out before we can tell, okay, this person passed or this person failed. So that is all about probability. Look at this other example. There is a 30% chance that this job will not be finished on time. 30% chance. We do not know until the job is finished or until that day is over. You cannot tell, okay, this job will continue the next day or finally this job finished. You get it? So we're going to give more explanation on these statements. But first of all, let's look at this one. So in each case, that's in each case of those statements that I just read to us now, in each case, we are expressing the outcome of which we are not certain. We are just expressing outcomes that we are not sure of. He said, but because of part informations or from understanding of the structure or the experiment or event bring about some degree of confidence in the validity of what? Of statements. So let's say, like the first example was like, we are not sure that Nigeria will win the football match against Norway. That is a probability that they would win. So the information we must have gathered that will make us say, no, I'm standing with Nigeria. Nigeria will win. It might be as a result of some past informations that Nigeria has played with some other, other team or other opponents, how they discuss about it. Those in football can tell, and they will say, Nigeria has won. Nigeria is good. The footballers there are solid. They know how to play their games well. So that would give us a level of confidence to say, in this one, Nigeria will still win. You can see it now. So, but still, it's still a probability until that match is played. Second example is writing of the exam. You are not sure if she will pass the SSCE. The same thing. Maybe what will give us another level of confidence is that maybe she has written an exam lower than the SSCE. Let's say she has written NECO, or she has written Junior WAEC and she cleared her papers well. Or let's still say she has written a mock exam in preparation to write her senior WAEC and she did excellently well. That would give us a level of confidence that if she goes for this SSE, she will pass. Another example again, there is 30% chance that this job will not be finished on time. It might be as a result of the nature of the people who are doing the work. Maybe they are the lazy type. Maybe the work started since morning and they have been so nonchalant, resting here and there. You can actually tell there's a level of confidence that you have in that scenario that this job might not finish on time. So it's just based on the information we must have gathered that will bring about some degree of what? Confidence in the validity of the what? Statements. Now, let's look at some words that are used or terms used in probability. One, we have chances. If you watch all of them, no words are so positive. They are just chances. You don't know. It's just guess. So chances, possibly it may happen. It might likely happen. Success, you don't really know if the person is going to come out. Failure, you don't know if the person is going to fail or pass, whatsoever. Etc. These are words used in what? Probability. So he said they are examples of words used in probability what? Statements. So we'll be looking at definition of terms used in probability. Definition of terms used in probability. The first one we're looking at is the sample space. The sample space, a set of whose elements represent all possible outcomes of an experiment, usually denoted by S. For example, this is the set of all possible outcomes of an experiment. What kind of experiment is this? A single throw of a die. How many of us know what a die is? Yes, it's like a cube shape. We use it in playing Ludo. Yes, so that's a die. It has 6 pieces. So it's like this. Die. So like this. So it has 1 here. In this part it has 2. This other part it has 3. This for the top. And at the back here it has 4. Here it has 5. And this down part here it has 6. So this is what we call a die. It has 6 faces, each one of them are numbered 1 to 6. So that is this one. And another example is the tossing of a coin once. Tossing of a coin once. How many of us know what a coin is? Most of us were not born when the use of coin was in vogue. So we might not really know. We might know. So a coin has a head and a tail. Has like the front and the back, just like our money, our Nigerian currency or whatever currency that we have, paper form, coin form, whatsoever. It has the head and the tail, the front and the back. So in this part, we use the head and the tail for coin. So when the coin is tossed once, tossed means it are thrown once, it can land on the floor to give you the head, it can land on the floor to give you the tail. So that's what we mean by toast once. Then, and the third example is saying the toasting of a coin of 2 coins. So you can toast 2 coins at the same time and it will land and give you a head and a head. You toast 2 coins again, it can give you head and the other one will give you a tail. You can toast 2 coins again, it will give you a tail and a head. And you can toast it again to give you till, till. So these are probabilities. These are the experiments being carried out, and these are their outcomes according to this definition, sample space. Then the launching of a missile from a submarine can either give you success. When you launch a missile in a submarine, you might either be successful, or you might actually not be successful. So if you're not successful, that is a failure. If you're successful, that is a success. Hope that is clear. So we look at the next term, which is the event. Event is any subset of the sample space. Remember, I showed us what sample spaces are. We had an example under the coin to be thrown. When 2 coins are thrown, we have 4 results or 4 outcomes. So now I want to explain what a subset of the sample space is. It said, consider the experiment of tossing 2 coins, and we have this result for the sample space. So how do we get the subset of this sample space? For example, then the event E, that the head appears on the first coin. So what is the event E of the head appearing on the first coin? Remember, I told us 2 coins are thrown. So let's say this is the first coin and this is the second coin. So when I throw the coin, probability is that it will give me head, head. Are you getting it? Throwing the coin again, probability to give me head again, tail. This will change. Probability throwing it again to give me tail here and a head here. Are you seeing it? Probability throwing it again will give me tail, tail. So how many head do we see appearing on this first one? In this first coin? 2. That is head, tail, head, head, and secondly head, tail. So that is 2 subsets. And that's what we have here. Head, 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 tail. The head appearing first. Hope it's clear. Alright. So we continue from here. Outcomes. It refers to all possible distinct results of a trial. Like we have here. These are trials and these are their outcomes. So I can explain it better by saying how many times one occurs in a particular trial, how many times all of this occurs, and this is what we have here. Then the concept of outcomes is similar to cardinality in sets, that is number of A or number of B depending on the given set. So we have here another term used in probability is experiment. This is the process through which outcomes are generated. The acts of throwing a die, tossing a coin, etc. are examples of what? An experiment. So experiment can also be called trial, just like we have here. So it's a process through which outcomes are generated. Outcomes are like results, through which results are generated. First of all, outcomes cannot just come up. They are a reason, or they are generated from experiments being performed. So if there are no experiments, there are no outcomes. Hope that is clear. So looking at the last 2 terms used in probability, we have the at least and at most. So most times we are very confused with these 2 terms, but I'm going to break it down in this video. So at most means the given number or less, while at least means the given number or more. Hope that is clear. So for example, if Tosin asked his classmates to lend him at most 200 naira, the classmates can as well give him 5 naira, 10 naira, 190, as any of these amounts will solve his provided will solve his problem provided the money is not above 200, because we already said it that at most means that particular number or less. So if they give him 200, it will solve his problem. If they give him any amount below 200, can also solve his problem. You are not allowed to give him more than 200 because he said at most. He was the one that said so. But if in another case he says at least 200, which means as you are led, if you can give him more, he will appreciate it as well. So I hope it's clear. So we should know the kind of statements we use in public, in communication, so that we don't limit ourselves to some particular blessing or particular amounts. Hope is cleared. So in at least, using that same 200 naira as an example, if someone says, please give me at least 200, so that is the smallest amount you can give him. You can give him more. So you can give him 1,000, 1 million, that's what it means. But when you say at least 200 or at least 1,000, which means don't give him, if you say at most 1,000, it means don't give him more than 1,000. That is one thing with probability. That's why I've taken so much time to explain all of these things, so that when we start having some examples, we will not be confused. It's better we get this cleared. This particular video is so long, and it is for this purpose of getting things cleared. Hope that is okay. So we'll be looking at the general formula for solving probability. The probability of an event happening can be given a numerical value x. We can regard it as x. That's what it means. So where x is equal to the number of required outcomes all over the number of possible outcomes. So the top here, or the numerator here, explains or signifies that this is what you are asked to look for all over all possible outcomes, all possible cases that thing can occur. So now we're still looking at situations in probability. We need to know all of this. Very important. When x is equal to 1, it simply means if the probability of an event is 1, then it is sure to occur. So when x is equal to 1, it simply shows that that particular thing is sure to occur, is certain to occur. When x is 0, you know it's the opposite. It is impossible to occur. It will never happen. It will never occur. So see, the range of solution to probability problem is between 0 and 1. Nothing above or below that. So in probability, we don't work with negative numbers. We don't work with negative answers, and neither do we work with values greater than 1. So it is always between 0 and 1. It is starting with 0 and ending with 1. That's the meaning of this range. Alright, so looking at the very last part of this video, for any event, the probability of success plus failure is given as 1. The probability of success plus probability of failure is equal to 1. So this x stands for success and the bar x stands for failure. So the probability of the both of them is equal to 1. Now looking at this last one, the probability of failure or non-occurrence or not happening is what? Probability of x equals to 1 minus that particular thing not happening. So these are formulas we are going to use, we are going to put in place when solving any example under probability. Hope you enjoyed this very long video. Yes, it is long because it is essential. It is so important, very essential. So go over it, make sure you are grounded in all that I've explained, and then let's dive into so many examples under this probability. I'm so sure you're going to enjoy this video and more.